thanks everybody for coming. I appreciate it. Good turnout. This is good stuff. This is my second time talking at DEF CON, and it was a good turnout both years. I am Jacob West. I run security research at Fortify Software, and Matthias is one of our researchers. I'll let him introduce himself in a second. But I came to the security world because I worked on static analysis. So I worked on a static analysis tool at Berkeley for looking for security vulnerabilities in C and C++. And I got really excited when on our last project with that, we applied it to the entire Red Hat Linux distribution. So it was like over 100 million lines of code. It was the biggest static analysis exercise to date. And what it turned up was we could find a bunch of bugs, and bugs that were easy to report, easy to fix, easy to deal with for the most part. And so that got me really excited, and I joined this company called Fortify, and since then we've been building static and now some dynamic analysis tools to find security vulnerabilities. I got to write a book a few years ago called Secure Programming with Static Analysis with a colleague of mine, Brian Chess. That's a great reference for any programmers out there who want to understand how sort of static analysis as a technology and software security can come together, and how static analysis, which is good for hammering all different kinds of nails, is particularly good at the software security problem. As I mentioned, my co-host today is Matthias Madou. Matthias, you want to introduce yourself?
Yep. So I'm principal security researcher at Fortify Software, and at Fortify Software I focus mainly on developing new techniques for finding vulnerabilities. This by doing static analysis on source code and dynamic analysis on running apps. Another project that I'm working on is developing new ways to protect web application firewall. So we have some sort of a web application firewall, but it's inside the application, so it's context sensitive, so we can actually do a better job. Last year I contributed to the BSIM Europe project. I'm not sure if you're familiar with BSIM, but BSIM is a maturity model that is...
I'm sorry to interrupt. I'm curious about this audience. Who's heard of BSIM?
Oh.
That's more than I expected.
Yeah. So BSIM, for the other people, BSIM is a maturity model that is based on real-world data from leading software enterprises. So this model can help you actually shape and plan your software security initiative. And when I was a researcher at Ghent University, I developed a code obfuscation and binary rewriting tool. So that's a little bit my past. Up to you, Jacob.
All right, fantastic. So I'm going to get us started today with a little background on what we mean by the insider threat problem, what we mean by an insider, what kind of threat they might pose. Matthias is going to go through a series of examples and kind of a classification of the insider threats, the code level that we've identified, and then I'll talk some about what tools people trying to protect against insiders have at their disposal, both in terms of process and technology, and then we'll conclude with the examples that Matthias already explained lined up against the defense techniques and the technology that I'm going to talk about, and showing you in the real world what we can actually accomplish today in terms of identifying insiders. So first off, last year 43%, more than 43% of organizations that responded to a CSI survey said that they attributed at least some of their losses to insiders, so people that were employed for their company, ostensibly working towards the same goals as the company, but that exacted some damage deliberately. I like a definition that Bishop and Gates is from CA Labs, and Matt Bishop, of course, is at UC Davis, used to define the insider threat. So there are really two kinds of threats that we're worried about here when we talk about an insider, somebody inside the organization. One is they have some existing set of permissions, access to some resource, something of value, and they use that in an incorrect way. So they have permissions legitimately to read all the users from the database because they work in support. But when they take that information and send it to their buddy on the outside, or use it to spam all the users, then they've used legitimate access for a nefarious goal, some illegitimate use. The other class we're interested in are insiders who gain some access that they're not supposed to have. So they're supposed to have a user login that would let them query their own account in LDAP. They hack into the system and gain access to an admin login that can update all the records in LDAP. That's gaining more access than they were intended to have. So you can take legitimate access and do illegitimate things, or you can gain ill-gotten access, illegitimate access, and do more than you're supposed to be able to do with it. Of course, insiders can fill all kinds of roles. So we hear a lot about IT people. We hear about people on the support team. We hear about all kinds of users who might be upset with the organization or want to do some damage. At Fortify, and from our backgrounds, we're interested in software. We're software people. So in particular, we're going to talk about developers and what kind of an insider threat a developer with access to commit code to whatever your organization's code base might be, what kind of damage they can do, and how we can identify the kinds of problems that they introduce. So what motivates a malicious insider? One of the most interesting stories I have from 2 or 3 years of working on this is a board of directors contacted our senior management and said, what can Fortify do to help with insider threats? And we said, the board of directors is asking about IT, insider threat, programmers. They don't know those people. What are they doing? Turned out they were getting ready. This was a big financial institution around 2008. And they were getting ready to lay off 6,000 programmers. They were really worried about, one of those programmers that they were about to lay off leaving something behind, a time bomb, some sort of malicious logic to do some damage to the organization. So they had started pushing their internal security team, what are you going to do to protect us against this? What's your process and technology in place to avoid these insiders doing damage? And in this case, these two potential motives, right? Revenge, this is the first and foremost. But also maybe monetary gain, right? If I'm going to screw the big guy, maybe I can do a little good for myself on the way out. These come up again and again. And these are the concerns both that drive and motivate the insiders and the concerns that organizations looking to stop insiders focus on and what really motivate effort in this area, like the work that we have done. So we're looking for developers. We're looking for developers who might be trying to bring monetary gain for themselves or do some damage, get revenge against their company. The main crowbar, the main tool the developer has, in contrast to an IT administrator or someone on the support team, is code. They get to check in code. They get to control the software in some form or another. Now, we'll talk about a lot of examples today and how just checking in code to do something really nasty, it's not quite as simple as just checking in code to do something really nasty. You've got some concerns like not getting caught in the way too, and how that functionality is actually going to execute as part of a greater system. But in the end, what we're really looking for is bad code. And we don't necessarily mean code that is vulnerable. We'll see a lot of examples today where the malicious insider code has a perfectly legitimate use. Except that's not the way it's being used in the case that we're looking for. It's being used illegitimately. So where do you find examples of this stuff? If you want to find the newest way to write a SQL injection vulnerability or the latest and greatest JSP tag cross-site scripting example, there's plenty of open source out there. You can find examples of these vulnerabilities very readily. If you can't find it there, then you can go talk to companies and you can say, okay, you've got cross-site scripting. We all know you've got cross-site scripting. Why don't you show us some of it and we can help you detect it and avoid it in the future. People don't want to talk about insider threats. If you've been bitten by an insider, then it means you had some employee that you hired and paid a paycheck to every month and they tried to bring your company down or they tried to steal from you. It's one of the most embarrassing problems in the software security field. And for that reason, it doesn't crop up a lot in open source because who's the target? Who are you trying to get revenge against there exactly? And companies that are actually susceptible to these or have been bitten by these don't want to talk about them. They don't want to show you examples. They don't want to even admit that it's happened. So coming up with examples is a real challenge. There have been some notable examples in open source or public disclosures of closed source examples of this. We'll show some of those later today. Some of our customers have at least gotten close to showing us the real thing. They're like, well, it looked kind of like this, except we changed a few things around. So that at least gives us an idea. But one of the most useful sources of examples that we found was a contest run at Stanford in 2004 called the Obfuscated Voting Contest. And the goal there was to write an electronic voting system that contained malicious code, basically an insider threat to miscount votes and skew the results of the election subtly towards one of the candidates. So in this case, we had 40 or 50 strong programmers come in and try to circumvent a review, try to keep auditors from finding their insider code from their time bombs or whatever it might be. And we found that this was a great example of the techniques that programmers are likely to use to try to avoid detection. So between these three sources, we've come up with the examples that we'll talk about today. We have to acknowledge some related work here. This is a relatively new field, but there are plenty of people that have made important contributions. Wysopal and Eng published a great paper about using static analysis on binaries to detect backdoors and other insider threats. Jeff Williams has done work in this area. Matt Bishop, who I mentioned earlier, and various co-authors of his. He's approaching it very much from we need an academic underpinning for all this. We need to define the terms and give formal definitions for what we mean by an insider and a threat in that context. And then finally at CMU, there's a research group called Scilab that's doing work on the insider threat problem more broadly. And they've actually, with a little coercion, focused somewhat on developers and programmers, code-level insiders. So this is a particularly interesting one for us. Okay, so there's our background. I'm going to hand it over to Matthias to go through some examples and classifications of different sorts of threats that we're concerned about. And then we'll come back and look at some of the techniques we use to defend against them.
Okay, so there are like numerous ways to classify insider threats, and to give you an idea, I'm going to go through a couple of examples, and I will try to classify them. So I have 3 examples up here. First of all, it's the Medco case. So after a particular date and time, it will delete over 70 all the files on 70 servers. So first of all, we can classify this as a very destructive insider threat. Another way to classify this is it's of high risk of the company itself for the business. If this piece of code is executed, well, it will delete 70 servers, which means downtime, which means no business. So it's like of a high risk for the company itself. It's also trivial to write this piece of code. It's not complicated at all. So you can classify this as a very trivial way to implement. Depending on where this code lands in the application itself, it's like an auto trigger. You do not have to manually poke it. You just have to wait until a certain date arrives and it will execute. So a fourth category can be like, it is an auto trigger. The second one is from Linux, and the functionality of the if statement should be like the following, like 2 flags for a particular command can only be executed when a person is root. So the options, you're going to compare the options again, clone and wall, and you check if the user is root or 0, and then you can actually use that function, use the if case. But something is wrong over here. Can somebody tell me why my, yeah? Yeah, correct. So it is not trivial to see, but over here, this is not a comparison. It's setting the value, setting the user ID to 0, not comparing the user ID to 0. And this is a little bit blended into the code. It's not like a separate statement that says, hey, we are making the user ID root. No, this is in the if statement itself. So this is definitely trying to hide from a manual auditor. Another way to classify this is this has to do with authorization. So only the root person can execute this particular command. Over here we have a problem, so this can also land in another bucket, which is like authorization. The third one was a Borland interbase case. So at Borland they had like a software design problem, and the way they fixed it, they had like a chicken and an egg problem about authentication, and the way they fixed this was by inserting this line of code. So they hard-coded, checked if the username was politically and the password was correct. So this works if the code is closed source, but of course when you open up the source to everybody, if you make that source, if you make it open source, everybody can spot this line of code and everybody can grant himself access to the code. So the way we can classify that one is in 3 ways. So we can classify it as an authentication modification. We can also classify this as hard-coded sensitive data that's in your application. Should not be there. Hard-coded username, hard-coded password should not be in your application itself. And a third way to classify this is it's actually abnormal control flow path creation. So this normally should not be in your application, so you're creating an additional control flow through your application that bypasses the authentication mechanism. Oops, sorry. So the way we actually classify insider threats is based on characteristics to spot the insider threat. So later on in this presentation, this classification will become clear. So now it's a little bit odd to look at this, but during the face-off, I'm going to explain how we actually find these insider threats in your application, and then it will become clear why we chose these classes of classification of insider threats. So what I'm going to do next is I will go through these classes and I'll give you some code examples. So I'm going to explain the class and I'm going to give you some code examples. So I will not show you how you can spot it in your code.